Welcome to Protein Innovation, Shaping the Future of Microalgae Foods in Europe webinar. It's a 1-hour webinar. We have 3 excellent presenters today. We have Josep, Israel, and Marie, and they're going to walk us through some of the future innovations that we're seeing in plant protein. So we're going to start out with a quick welcome from Gerard, our CEO at Bridge to Food. And then we'll have Josep's presentation on the future of microalgae and foods. Then we'll have a brief Q&A, followed by a presentation on baked goods development with Israel. And then we will have innovations in microalgae and pasta with Marie, and another Q&A, followed by a brief closing from Gerard and some insight into future events that we have coming up.
Yeah, I think welcome to all of you. From wherever you're calling in. I'm always excited to know where you're coming from to try to picture your environment, but that's a little bit difficult. If you like, then just mention it in the chat. The purpose of this webinar, the purpose is actually that you will hear about some great science and developments and breakthroughs that are happening within the project. The second is actually that there's an opportunity for you to connect with them and maybe form new type of relationships. And the third one is that you connect with each other, because you might have something that somebody else can need and want. And that's why I think Barb and Shannon are also explaining. Do introduce yourself in the chat. Don't be shy. When you give something, you always get something back. And all of a sudden, you might find that you are connected. Thanks, Max from Delft. You have sunshine, I'm sure, because we have sunshine here as well. Now, a few little comments, I think, on this project. The presentations that you will see here are part of a 4-year project that has been funded by the European Commission under the so-called umbrella Horizon, I think 2020. The project started October 2019, and then, irrespective of COVID, everybody worked very hard to continue. And the project will be finished October 2023, a 4-year project. 31 organizations being part of that, 13 different countries, probably 10 over universities, working on things that are always very important when you start exploring new opportunities. And the EU is very keen on working on new plant proteins, alternative proteins in different stages of development. So this project has a work package on finding new strains. What is the optimal and the best algae? There's work being done on extraction, on purification, on growing, all sorts of things technically to make the algae work so that you can extract the right ingredients from it. Today is a webinar about the last part, which is very much about finding applications and testing applications with existing strains, with new strains that have still been developed. And I think you all are hopefully very happy that you will find 2 expert organizations here that have done great work. It's the IRTA Institute in Spain, a very famous leading institute, and from Germany, at the border with the Netherlands almost, there's the Dill Institute in Quakenbrück, where Marie-Christin will speak about findings in pasta. So that's the storyline of the webinar. The project will continue for another 1.5 years. So feel free to come back and ask questions and be engaged with everything what's happening. So I think that's all I wanted to say about the context. And then it's my great pleasure to welcome Josep Comaposada, if I pronounce it right, Josep, from the IRTA Institute. You are a work package leader. A work package leader means in the EU terms that you are managing a major part of a project for different reasons. And IRTA is the leader of this great project. Great.
Well, then thank you very much. And good afternoon or morning to everybody, depending on where you are coming from. And I will start presenting just a little overview of this ProFuture project, and I will follow with some of our development of food with microalgae. Now, okay, first of all, I would like to show this figure that probably many of you have already seen. From this figure, it comes out the importance of protein needs in the near future due to the growth of populations. According to it, in 2050, we will need 52% more of protein. The problem is that the global protein production from conventional sources, it is going to be restricted by environmental or technical factors, and it is not sustainable over time. Therefore, microalgae can be an alternative protein source to help to meet the population's need. They have a high photosynthetic efficiency with higher growth rates and productivity compared to conventional terrestrial crops. They do not compete for land with crops used for food or feed production. They have a high crude protein content, about 30-60%, higher than that of dried skim milk or soy flour or chicken. And their amino acid profile is superior to that of soybean or other plant sources when considering the essential amino acid contents. And it is also a polyunsaturated fatty acid source. But of course, several bottlenecks still must be overcome to make a reality the large-scale production of microalgal-based protein and ingredients, and the incorporation of this algal material into palatable food preparations or suitable feedstuff. Therefore, the ProFuture project has the objective to address these bottlenecks and to demonstrate the technical and economical feasibility of the innovative solutions, as well as to prepare the market uptake and determine consumer acceptance of the innovative products. The ProFuture project follows a multi-actor approach, bringing together expertise from different fields, from academy to industry, to develop and validate innovative solutions all along the microalgal value chain. As you can see, from the biomass production and processing to food and feed production, and considering all the aspects related to distribution and logistic, consumer behavior, regulation, business model, and market strategies. Work Package 3 focuses on developing and implementing major innovations in algae biomass production and harvesting by reducing the production cost through strain improvement and selection. Work Package 4 is assessing at lab pilot plant scale several technologies for the affordable and sustainable production of two types of protein-rich ingredients, the single-cell and protein isolates. The Work Package 5 for food and feed products is addressing the reformulation at lab and pilot scale of innovative food and feed with single-cell and protein isolates to overcome obstacles, the obstacles like defective food structure, undesired color, or aroma smell, which may limit their incorporation into the target matrices. The Work Package, the food company partners are involved with the development of bread, soups, sport drinks, snack bars, sausages, and vegetable creams for the addition of microalgae. Work Package 6 is about the scaling up at industrial level. Work Package 8 is analyzing the whole microalgae food and feed chain in order to identify the different actors and the logistical constraints, as well to analyze the environmental and economical sustainability. And Work Package 8 is assessing consumer perception, acceptance, and preference for microalgae protein. The first information we obtained from our partners was the definition of the prerequisites for the microalgal protein-rich ingredients to be added to the different food matrices. It was concluded that two types of microalgal protein-rich ingredients were foreseen to be developed: the purified microalgal proteins, or protein isolates, and the bulk microalgal, the single-cell proteins. The differences between the two products are mainly associated with the protein purity, above 60% protein content in the purified microalgal proteins, and about 40-50% with the bulk microalgal proteins. But there are other differences. For the purified microalgal proteins, it is demanded emulsifier and stabilizer capacity, high digestibility, the presence of essential amino acids to have a light color and a pleasant or neutral taste. For the techno-functional properties, other parameters must be considered, like water solubility, water and oil holding, foaming or gelling, among others. Between our partners, a general interest was shown towards low-price products, about 10 euros per kilo. Medium-high prices, 30-50 euros per kilo, were accepted for animal nursery feed to boost the animal growth, and medium-high prices also for the vegan food with the right amino acid profile, vitamins, and antioxidants. Of course, all this information helped us to identify some critical points on the development of foods with microalgae according to the actual knowledge on this microalgae, and thinking with the consumer's acceptance and their willingness to pay for the quality on these products. Before starting any development, several points are used to be considered. The first one is the purpose of the microalgae inclusion into the food. Do we add the microalgae to increase protein content, or do we add it for increasing the antioxidant value, or whatever? But it's important to fix the purpose to face properly the development. The second is about the expected attributes of the products that are also important. Maybe it's easy to accept a green color in pasta or in a vegetable cream, but will it be accepted for sausage? The same happens with the odor and taste. And depending on the product, it becomes difficult to mask the flavor with aromas or masking agents. Texture can be also a critical parameter, although at the levels of addition normally used below 10%, usually do not become an excluding factor of the microalgae addition. Nevertheless, it must be considered for the processing parameters. The functional properties can limit also the addition of microalgae protein in some foods. As example, the water solubility may depend on pH, and this could affect the inclusion of microalgae proteins in beverage, for example, among others. No? Finally, consider that the market objective can affect the success of our developments. It can happen that a vegan consumer is willing to accept products with the attributes not associated with the conventional products, but maybe other consumers can reject it. Knowing the needs, we must look at which microalgae strains fits best to our product. The attributes changes in compositions, aspects, and technological properties depending on each strain. At the beginning of the project, only 3 strains were available for food developments. At this moment, we have some other strains as a result of the research and development done. These new strains are more appropriate to add them into the product for its color and taste impact. In this slide, we show the aspect of several strains. If we wish to avoid a color impact in the product, of course, then the white or honey or golden chlorella strains will fit better to our objective. Therefore, the strains improvement and selection becomes an important task to facilitate the addition of microalgae into the foods. An example of development in foods is the addition of microalgae in vegetable creams, where the objective is to have a vegetable cream that can be labeled as high in protein, in which protein provides more than 20% of the energy. Depending on the microalgae strain, the level of addition changes. Only 1.5% spirulina is required to be included to be labeled as high in protein, while if we use smooth chlorella, it is required 4 times more, 6%. We can see the changes in color due to the microalgae addition, but the smell and taste are also different. And the most different one of them is the vegetable cream with Tetraselmis chews that has a stronger fishy odor and salty taste, since Tetraselmis is growing up in seawater, while the others have been growing up in sweet water. Finally, the last example is a development of adding the microalgae in energetic bars, where the objective is to improve the nutritional value of the energetic bars. In the image, we can see the impact of the strain and its level of addition on the color. Other texture parameters are still analyzing. But once the most successful formulation of each product are obtained, the next step is to validate the best ones with the consumer study to assure a good success in the market. And that's all. Thank you very much.
Thank you very much for a great presentation, Josep, and for sharing the insights and all the beautiful colors as well. The recommended maximum consumption for microalgae per day. She says, is it 5 grams per day, or is it less or different?
Usually with the sweet microalgae, there is not many constraint about it. Maybe in the algae that has been growing out in salted water, maybe iodine can be a limit. But it depends also, because the iodine concentration is not all constant always. Then it's good to know these values that can limit just this daily consumption. But the sweet algae, no, it's not this limit.
Maybe Celine is also referring to the recommended daily intake from a regulatory point of view, not so much from taste, but from a regulatory point of view.
Under my knowledge, there is not any restriction.
Yeah. All right.
These heavy metals that can have the.
Okay. Well, maybe Celine, if you like to leave your message, or we leave the email message of Josep, you can be in touch with each other later on this topic. And if anybody in the audience has a question or an idea about this, feel free to share, so that we will all gain a little bit of extra know-how. So my question would be maybe to you, Josep. You've explained, right, what you have been doing all the way to bars. Is there now something that you're going to do in the next, let's say, 18 months on finding new applications?
We will work also with energetic drinks. Okay, we'll try to to add some isolate proteins in energetic drinks. Of course, we need to go further with the energetic bars and also the creams, but okay, there's still a way to go. But I hope we can finish with good results. Yeah,
okay. So the focus is on a new application and bars, right? And there's a question here from Tim, I think. I saw it looks like he wanted to raise his hand and then pull back. Tim, do you still would like to ask a question? Come forward, I think. Not sure if it's possible.
If Jim can write the question in the chat, there's another one I see here from Iomid.
Yeah, okay. If you could do that in the chat, Jim, I think there's a technical thing by giving you speaker rights or something, if that's okay to type it. But meanwhile, the question from what's the freshwater algae strains popular in the food industry? What are the freshwater? The freshwater, the sweetwater algae strains popular in the food industry.
Well, spirulina would be the one, the sweetwater. Spirulina would be the most popular, the most known. But now chlorella, vulgaris chlorella, is also a strain that we are working with and developing product with them. But probably spirulina is the most common, or the most known one.
Yeah. Also for supplements, dietary supplements.
Exactly.
Yeah. Shannon, can we take 2 questions before we move, if you have time?
That sounds good. I see one from Iomid right now. What are the challenges being encountered in production of protein for microalgae, and about scalability?
What are the challenges being encountered in production? Okay. This should be better to address to to our colleagues in Work Package 3, because they are working with this issue. Yes, I better just do.
Perfect. And then there's another one about, do the cells need to be burst to be digestible?
Well, I don't know. In fact, we are using with energetic bars, and they are not burst. But I don't know the differences on the quality, really.
Maybe the idea is here that you have a pH 1.6 in your stomach, right? The pH will maybe have an effect on the cell walls, and then the cell walls will open, and then the omega-3 and the other nutrients can come into your bloodstream or into your intestines. And in some cases, maybe the algae are not digestible because the cell wall is too hard. So we add it, but we don't maybe get the nutritional value from it. I think that's behind the question.
Yes. Could be. I cannot answer, really.
Please continue with your questions, and maybe Josep and Marie, and also later on Israel, you can answer to the questions as well if you know something, right? Okay? Please feel free.
Okay.
Then indeed, we are moving from the bars to another baked good with Israel Hernandez, and he is with also IRTA as a ProFuture partner in Spain. And
yes.
Please explain what you've been doing.
Okay. Well, I'm going to be talking about bakery products developed with microalgae additions. In previous work, we have been working with 4 different strength levels of flours, being this Manitoba, bakery flour, whole meal flour, and organic flour. These were assessed with 2 different levels or concentrations of spirulina to see what was the impact of spirulina protein within this bread matrix. As you can see in this label, it can be seen that the spirulina protein or the spirulina biomass had an important impact both in texture and color of bread loaves. As it can be seen in the bakery one was the one without or was the one with higher impact in the loaves height. As it can be seen, the alveolar structure was impact, and it has a greenish colorization. In this case, this project was developed like 1 year ago, and it was the obtained results were that sorry. Sorry, technical issues. But in these steps for the ProFuture project, we were assessing spirulina, chlorella, and tetraselmis biomass in 3 different levels or concentrations: 1.5, 2.5, and 3.5% in the addition of grissini or breadsticks, crackers, and muffins. These products were evaluated according to another ProFuture partner, the Kale's formulations. First, we have the grissinis. As you can see, the dove aspect with the different concentrations of microalgae are kind of funny. We have 3 different greenish colorations depending on the concentrations of the microalgae added. Here we can see the already baked breadsticks that were after assessed nutrimentally and sensorily analyzed by a sensorial panelist of 30 people. As in total protein content, we can see that against the control samples, the protein enhanced that microalgae enhanced the protein content with the 3 different microalgae, Tetraselmis, Chlorella, and Spirulina. Both Tetraselmis at concentration 2.5% and Chlorella 3.5% were the ones that had the highest levels of total protein content from these breadsticks. According to the analysis carried out, we can see that the antioxidant capacity for these microalgae were higher with spirulina at concentrations 3.5, with a DPPH analysis, and for FRAP antioxidant capacity was also spirulina at concentration 3.5. These analyses were carried out with fresh weight samples. And also for total phenolic content, you can see that at concentration 3.5%, spirulina had the highest levels of total phenolic content. To continue with the sensorial analysis, it can be seen that the results are kind of similar for the 3 different microalgae, but it can be seen that that Chlorella at concentration 2.5 had the higher global acceptance. So this will be the result for Gricinis. Here it can be seen, as I was commenting before, that Chlorella at concentration 2.5 had the highest likely moderate global perception level, and this is a good result since at higher levels of microalgae, the people had perceptions of tasty salt or like a salty taste in samples. But it can be shown that at this concentration, people can accept this microalgae in bread sticks. Then we can go to a muffin analysis. These were assessed the same way with tetraselmis, chlorella, and spirulina, the same concentration as I told you before. These were the results. The higher impact of microalgae was in tetraselmis with a greenish coloration, with a harder greenish coloration, depending on the concentration against the other two microalgae and the control samples. Total phenolic content and antioxidant capacity were also measured, showing that chlorella in both concentrations 2.5 and 3.5 had the highest amount of antioxidant capacity, that is according to the total phenolic content that was assessed to these muffins. As you can see, FRAP has the same results. For sensorial analysis, it can be seen that muffins with chlorella concentrations at 2.5 and spirulina 1.5% have the better global acceptance against the other concentrations or the control samples. And finally, we have a crackers assessed analysis. These are the crackers that were analyzed and sensorially proven by the panelists, the same concentrations and the same three microalgae. Antioxidant capacity was higher for the concentrations in 3.5% in the three microalgae, as the same as in FRAP, and DPPH and total phenolic content had a higher concentration in 3.5 for spirulina. Global acceptance in crackers was better for chlorella and spirulina at concentrations 1.5, and these are the packages that were developed and given to people so the sensorial analysis will be carried out. For overall conclusions, we have that Gricinis with a chlorella 2.5 concentrations were the most acceptable by people, followed by for the muffins with chlorella and spirulina at 2.5% or 1.5% concentration, and chlorella in crackers with 1.5 and the spirulina also 1.5%. These products will be next tested in real industrial conditions. Next step will be brioche nutrimental and physicochemical analysis. The shelf life analysis will be carried out within 6 months for crackers, grisinis, and croutons, and some product trials will be developed with gluten-free as a gluten-free products. Aroma additions and selected from selected formulation will be carried out also. And that's all. Thank you.
Many thanks, Israel. Go ahead, Sam.
I'd like to invite everyone to put their questions into the chat. And we have about 3 minutes for questions at this point. Maybe, Israel, could you let me know, how do you find the product testers? Are they like researchers, friends, people from the public? How does that work?
Sorry, I didn't understand that.
So the people who try the breadsticks, try the crackers, who are
Yeah.
they? Other people that work at IRTA or?
Yeah, the same people that works here at the center. So we were like from desk to desk, giving them the package with the crackers, the grisinis or breadsticks, and the muffins.
Perfect. And then I see one other question, but it's from Max, and it's, how do you cope with limiting off flavors caused by the algae? Is there something that you guys can do to enhance the flavor?
Yeah. For example, we have been testing different or trying to mix the products with regular based food, so it can be like this taste can be like lost, for example, previously, some 1 or 2 years ago, we worked on a wheat flour tortillas from Mexico that were mixed with fish and those kind of food. So this microalgae taste will be like covered, or yeah, that's what we have been doing more likely.
Perfect. Thank you very much. I see there's another question in the chat. If you'd like, you can respond to it in the chat. And I'd like to invite Marie to share her screen and give the presentation on innovations in microalgae and pasta.
Thank you very much, Israel, for a great presentation. Thank you so much. To introduce Marie-Christin Baune from the DIL Research Institute in Germany, a very important research institute where there's a collaboration between industry and actually the institute. Industrial companies are members of DIL, and then together they carry out projects within this scope or sometimes in the regional scope, right? Also for companies themselves. So a great experience in meat-free as well, looking at new textured products, and in high pressure, I think, how do you call it? HPP, and other new technologies. You are really one of the leading fields. But you're going to talk now about application in pasta. Please go ahead, Marie-Christin.
Yeah, thank you, Gerard, for the nice introduction, and welcome to everybody. So today I want to tell you a little bit about Chlorella vulgaris application in pasta. So why did we choose pasta? On the one hand, there was the project partner Tradizioni Padane from Italy. They produced traditional pasta and wanted to have pasta with microalgae. They already have a pasta containing spirulina, you can see on the picture. And the idea was to have addition of highly valuable algae ingredients in normal pasta. The acceptance may be good because green pasta already is accepted by consumers. A green sausage may be not the best product. And also storability of pasta is quite high, and especially for small companies who cannot produce large amounts, storability is a big question. So at the beginning, we only had one ingredient. It's the smooth Chlorella vulgaris from our partner microalgae. It's the light green Chlorella vulgaris that is produced by fermentation. And for the pasta, we only had two ingredients, the Chlorella vulgaris and Durumid semolina. And as you can see, comparing the macronutrients, so the semolina has a high carbohydrate content, while the chlorella has a protein content of 26% and also a high dietary fiber content. And especially in case of micronutrients, we have a high calcium and sodium content in the microalgae, but also a higher salt content. But especially this sweetwater microalgae that is produced by fermentation has a very low iodine content of 0.01 to 0.1 per milligram. And microalgae are famous because they have a lot of B vitamins, and also here especially vitamin B3, B9 and B12 are present, but in comparison to semolina also vitamin C, while, for example, vitamin B9 is lower. How did we make the pasta? We had a commercial pasta machine, which is normally used by gastro industry. And as ingredients, we only use tap water, the semolina and the smooth chlorella. And so kneading and forming was made by the machine itself. We're using different dyes for different types of pasta. Afterwards, the pasta was dried under specific conditions in a chamber, and then we made some physical analysis. So these are just some pictures. So we use 3% and 5% chlorella because the Tradizioni Padane, they prefer organic labeling, and since it's not an organic ingredient, we are not allowed to use more than 5% in the end. And you can see the fusilli, which we made for sensorial analysis, and the Zane plates, which we made for physical analysis because it's easier if you have a plain area. You can also see the small pictures of the non-dried Zane plates. And what you can see here is that normally they had a really cool bilious green color, but up on drying, they became a little bit more brownish. And due to the pasta machine dye, we always had the problem that the top side and the bottom side of the Zane plates had different colors. But this was a specific problem of this specific machine, and we could not overcome it. So in case of physical properties, we first analyzed how much water was still in the products after drying. We did this by infrared drying and just determined the water loss up on drying. And it was in all samples about 10 to 11%, which is fine with the EU regulation saying that in dry pasta, the final humidity must be below 12%. Then we analyzed the cooking time. There's a defined protocol how to do this. And again, for all samples, there was no significant difference, even though the control sometimes had a little bit higher cooking time, but also a higher standard deviation. We always did this in tap water without addition of salt, because some of the algae we tested, they have salt included, and this may changes the cooking time, and therefore we did not add additional salt to see the effect. And we also checked the water absorption, so how good the pasta is swelling in water. And here was a significant difference, so the swelling of both chlorella-containing pasta was slightly reduced. Then we measured the color with the colorimeter, so the LAB values. L is, in case of high values, the white, and in case of low values, black. A is red in case of positive and green in case of negative values, and B is yellow in case of positive and blue in case of negative values. And I always measured the top and the bottom side, and I did this before and after cooking. So what you can see in the graph is that the L value of the control pasta is much higher, so it's lighter, while there is always a difference in the uncooked lasagne plates between top and bottom. a significant difference, where this is not the case after cooking, except for the pasta containing 3% chlorella. And in case of the L values, the control is a little bit more red than the greenish chlorella pasta plates, but the chlorella pasta plates are a little bit more yellow. And we also calculated the Euclidean color distance. It's saying that if the values are quite small, you cannot detect them by the eye. So if they are around 1, but what we can see is that before cooking, they are really big. So we have values of 9 to 5, and after cooking, they are smaller. So we can definitely say, yes, the color difference of the bottom and top side is reduced after cooking. Afterwards, we also measured cooking loss and cut resistance. The cooking loss is very important because if the pasta is not stable, you may lose a lot of material during the cooking process. But again, for all samples, the cooking loss was quite small, and there was no statistically significant difference. And in case of cut resistance, we had one major problem because we made 3 independent productions, and the values of each production, they did not really fit to the values of the other productions. So it was a bit hard to compare the results. The problem is that for the lasagne plates, you have a specific die, and the gap is not fixed, so you always have to fix the gap again. We did this just with a small metal plate, but maybe it was not accurate enough. And if you have differences in the size of your pasta, then also the cut resistance is varying. And we always cook for 10 minutes, and if the pasta is thicker, they are not as cooked as if the pasta is thinner. So from the results here, we could say that the pasta with 3% chlorella, with 5% chlorella addition, and with 3% chlorella addition, both did not vary from the control, but they varied significantly to each other. In the end, we also made some scanning electron microscopy pictures just to see whether there are differences in the microstructure. So in the left, you can always see the outside, which was in contact with water, and on the right is the middle of the lasagne plate. And just to show you where I zoomed in, I marked this with the small boxes. So first, a picture of the outside. What we can see here is a mesh of protein structures, and that the pasta is swollen from the outside, and that the level of swelling is decreasing the farther you get to the middle of the pasta. And there's one big difference, because in the pasta containing 5% chlorella, there is a bigger mesh, and also the swelling is to a higher degree. And this indicates that they may have a marshier consistency. If we have a look to the inside of the pasta, you cannot see big differences. So there are typical pasta structures, especially starch granules, which are embedded in a gluten network. You can see on both sides. And beside the starch granules, you can also see sometimes very small round chlorella cells that are embedded in the gluten network. So from a nutritional point, we also calculated whether all essential amino acids are present, and whether there are changes within the mineral or vitamin content. So what we can see if we compare semolina and chlorella is that in semolina, lysine, lysine, and threonine are limiting, while in the chlorella, non-essential amino acids are limiting. But when we mix them, so 3% chlorella or 5% chlorella. We increased the amount of these essential amino acids, but still leucine and lysine are limiting. And in case of the mineral as vitamins, we got a higher content in calcium in the mixtures, in zinc, and also in vitamin B3, but also a lower content in vitamin B9. And all recipes allow for claims that they are source of protein or source of fiber, but this is just also the case for the control, because the semolina is composed in a way that this is true. So concluding, we could say that the processing was not differing, so the power consumption of the machine was the same for all samples. But we had the problem that the processing was not standardized, so we had different thicknesses of the lasane plate, and therefore the cut resistance was inexact. But I think if Tradizioni Padane is repeating the production on their own devices, the results may be comparable, and we can analyze the pasta then too. So there were nearly no changes in the physical properties of pasta containing 3% and 5% chlorella, and if there were differences, they were rather small. We have a slight improvement of the nutritional properties, but still leucine and lysine are limiting. Due to the organoleptic properties, so due to COVID, we had the problem that the sensorial studies could not take place in-house until now, but we now do the training of our panelists so that they are professional to compare the pasta samples. But what I can say is that of course they have very slightly fishy off odor and taste, which is more pronounced in the pasta containing 5% chlorella, but in my opinion, both products are still acceptable. And especially in the future, we will then do the quantitative descriptive analysis and acceptability test with the consumer panels to understand if the products are also ready for the market. Okay, that's it from my side. Thank you very much for your attention.
Thank you very much, Marie-Christin. Thank you so much for a lot of very interesting stuff related to Italian foods, which are always very yellowish or reddish because of the tomato, but now they've turned green. Let me have a look if there are some questions in the chat. Not at the moment. I was wondering maybe on the shelf life stability, right? The rancidity, the last slide that you mentioned. If you would make fresh pasta, would you have the same challenge, or is it only when you are doing it with, drying and then prolong the shelf life?
So I think if we make fresh pasta, of course, the color will not change.
Mm-hmm.
And then we have this nice barley green color, but of course, shelf life will be not as long. So I'm not sure, but I think 3 weeks or something like this is the normal shelf life for fresh pasta.
Yeah, and then would you then still have the fishy odor, or the challenge with the taste, you think?
The odor did not change. So the fresh pasta and the dry pasta was the same.
Same, okay. That was the question. All right. And Shai is saying the fishy odor might be a problem for vegetarians. They don't expect that to have in this type of food.
Yeah, but I'm not sure. So of course they don't eat fish, but I think they expect something if they buy a pasta with algae. And so I don't know, for 20 years you can buy these nori plates for sushi and so on, and of course you know that they taste fishy. So I am vegetarian, and I think it's okay. So I expect that they taste fish, so it's okay that they taste like fish.
They come from the sea, right? Yeah. And but the question of Shry is actually how to improve the odor, which is the holy grail. Do you have the holy grail, and where?
I think there's only one possibility, and that's to improve the ingredient itself. Because, so the only other way is to reduce the concentration in the final product. So you cannot eliminate the taste or odor of the product. So
Could you do it with CO2 extraction to get rid of the oils?
I think, maybe. We did not try. So what was done within the project is that new mutant strains have been created that contain, for example, less chlorophyll and therefore also have improved color and taste. And I did not show the results, but we also used the white and the honey chlorella to make the pasta. And they, of course, have a nice color because they look like the control in case of the white chlorella, and like a really nice egg pasta in case of the honey chlorella, because it's really a yellow pasta. And they also do not taste, or that they have a fishy taste, but it is really, if you don't know it, you would not recognize that they have been added.
Fantastic. I don't see any more questions, Shannon, do you?
No, I don't. Thank you very much, Marie, for your presentation. That was fantastic. I loved seeing all the pictures of the pastas and breads and different developments of the strains of algae today. It was it ended up being a full circle in the end of how to improve everything. So that was really great. Gerard, would you like to say a few words to close off the webinar today?
Yeah, that's fine. Well, the first thing I think is, let's say, we'll be back somehow in the coming year with a little update. So if you have any questions, indeed, as Shannon and Barb have mentioned, and also in the chat, you see the name of Massimo Castellari, who is the leader and the scientific coordinator of the project. So you might be able to connect with him on things that have been published. Because some know-how is also still in the development for publication, so that not everything can be shared, but you could really connect with the right people from a production, growing, or maybe processing point of view. To say a few words maybe about the bigger picture, when you talk about algae protein in particular. We just finished another webinar as Bridge to Food on mycoprotein. If you like to see the recordings, please feel free to connect with us. Also an EU project, which is great with the news source mycoprotein. And we will be doing a webinar which is related to our ecosystem, the ecosystem of Bridge to Food, on the investment opportunity. You know that in particular in Europe, more money is going to be set aside, hopefully, for research on alternative proteins. But they need direction. They need help. And say, where should we spend the money? And together with the European Plant-Based Foods Alliance and others, we are trying to work on getting more projects funded in the right direction in plant-based in the future in Europe. That's where this plant-based investment opportunity webinar is all about. Talking application, because this is an application webinar, we should look at the word courses. And at the courses, there will be, again, involvement of this project, where you might be able to taste and to see and to touch and to smell, and maybe to like as well, definitely, hopefully, these products. There is also going to be another company called Sophie's Natural. This is a startup from Singapore with an office in Wageningen, and they're working on, how do you call that, algae that are not getting any light. So they, how do you call this, Josep? Going the algae strains without light. Do you know? No. Well, it's a fantastic algae protein. It's white, because there's no chlorophyll being made in the algae. So there's a little bit more on algae at the course, but also other proteins that are being discussed, like soy, potato, black rapeseed, as well as spelt and barley. And then, of course, at the summit, Massimo will also be present to do a presentation on the project. And this is a little bit the timeline of what we are doing as Bridge to Food connected to these projects. Feel free to connect with Shannon or with Barb or myself if you have any questions about what we do and how we can help you, because that's what it's all about in this world, to help each other to make it easy and quick, convenient and fun. Having said that, I think if there are no more questions, I would like to ask you all for a big applause. Raise your hands for the three speakers, Josep, Marie-Christin, Israel, and also for Shannon and Barb to organize everything. Thank you very much. Have a fantastic evening or afternoon, and we hope to stay in touch with you.